Welcome to the 60th episode of AI Talks with Chris and Nita. Indeed, we've come a long way.
60 episodes already. Time flies.
It really does. And welcome everyone to the Deep Dive. This is where we take the sources you send us, dig in, and pull out the key insights.
Making complex stuff, hopefully a bit more accessible.
Exactly. So today we're looking at GLOVE. That's G-L-O-V-E, Global Vectors for Word Representation.
Right, a pretty important technique that came out, back in 2014 from Socher, Manning, and Pennington at Stanford?
That's the one. And the sources really get into this fundamental question. How do we get machines to actually understand human language?
Yeah, and step one is always turning words, text, into something a computer can actually work with. Numbers, basically.
So vectors. That's where word embeddings come in.
Precisely. Word embeddings are key. You represent words as these numerical vectors in a multidimensional space.
And the idea is that the position, the angle, the direction of these vectors tells you something.
It tells you about the meaning, the semantic relationships. Words used in similar ways should end up having vectors that point in roughly similar directions.
Okay, so that's the general idea of embeddings. How does GLOVE specifically create these vectors? What's its approach?
GLOVE's special sauce, if you like, is using global statistics. It looks across a huge data set of text.
A corpus, right?
Exactly, a massive corpus. And it builds up this giant matrix, a co-occurrence matrix.
Co-occurrence, meaning how often words appear near each other.
That's it. It counts how frequently word pairs show up together within a certain context window across the entire corpus.
Okay, so it knows which words are common buddies.
Pretty much. Then it uses some clever math to create word vectors so that the relationship between any two vectors, like their dot product, sort of reflects that co-occurrence probability. It optimizes the vectors to match the stats.
Interesting. And how does that compare to other methods mentioned, like Word2Vec, or maybe even simpler ones like TF-IDF?
Well, simpler methods like hot encoding or TF-IDF are more about presence or frequency, not really deep meaning. Word2Vec does look at local context, like words nearby.
But GLOVE focuses on the big picture, the global stats.
Right. Word2Vec learns from local context windows sliding through the text, while GLOVE specifically tries to capture these overall co-occurrence patterns from the whole dataset directly. Different philosophies, both useful. Fast text is another variant good with rare words, depends on the job.
Got it. So we have these GLOVE vectors, these numerical word representations. What can we actually do with them? What are the applications?
Oh, loads. This is where it gets really practical. Think about text classification.
Like figuring out if a movie review is positive or negative? Sentiment analysis?
Exactly that. Or classifying news articles by topic, or even spam detection. The GLOVE vectors give the machine learning model really meaningful features about the words being used.
Okay, that makes sense. What else?
Named entity recognition, NER. That's identifying things like names of people, places, organizations in text.
So understanding Apple the company versus Apple the fruit.
Well, context helps there, but GLOVE embeddings improve NER systems because they understand semantic relationships. A word vector for Paris will be related to vectors for France or city. That helps the system identify it correctly.
Right, it provides richer context. Any other big ones?
Machine translation definitely benefits. Representing words effectively across languages is tricky, and good embeddings help align meaning.
So better translations, hopefully.
That's the goal. Also, question answering systems. To answer a question, the model needs to understand the question's meaning and the meaning of potential answers in a text. Embeddings are crucial there.
Okay, so classification, NER, translation, Q&A. Seems like it underpins a lot of NLP tasks.
It really does. And things like document similarity, too. If you want to find documents similar to one you're reading or cluster-related articles.
You compare their overall meaning using these vectors.
Essentially, yes. You can represent documents based on the embeddings of the words they contain. Also, semantic search finding web pages based on the meaning of your query, not just keywords.
And that famous analogy thing. King minus man plus woman equals queen.
Yeah, the word analogy task. GLOVE vectors are often pretty good at capturing those kinds of linear relationships. It shows they've learned something meaningful about word connections.
That's quite a range. So, to boil it down, GLOVE is this powerful way to turn words into numbers that capture meaning based on how words are used together globally.
Which then lets machines process and understand language for all sorts of tasks.
A foundational piece of the puzzle.
Definitely.
So a question for you, our listener, to think about. As these AI techniques for understanding language get even better, how do you see them changing how we interact with technology day to day? What kinds of new applications might pop up when machines understand us even more deeply?
Yeah, it's fascinating to think about where this is all heading.
Absolutely. Well, that's all we have time for on this deep dive. Thanks for joining us.